Evaluating functions and expressions. A function can also be defined as an equation in two or more variables. Consider the equation y is equal to x squared. This equation states that for a given value of x in the domain, the corresponding y is the square of x. For example, if x is equal to 7, then y will be 49. The y value depends on the value of x. For this reason, y is called the dependent variable and x is called the independent variable. To show that an equation represents a function, function notation is used. Okay. F is the name of the function. F of x is the value of the function. It is the number, the output that is paired with x. X squared is the algebraic expression that defines the relationship between independent and dependent variables. The process of determining f of x for a given value of x is called evaluating a function. Okay. For instance, evaluating f of x is equal to x squared. When x is equal to 4, we replace x with 4 and simplify. Okay. So the function when the value is 4 is going to be 4 squared, which is going to be 16. So let's look at an example here. Now for this one, they want us to evaluate it when t is equal to -2. So for example 1 here, I have g of t is equal to 3t squared minus 5t plus 1. And we're letting t equal to a -2. So when I rewrite this, every place I see a t, I'm going to be replaced with a -2. So I want to find the value of the function g when t is -2. So after I've done that, I want to go ahead and simplify it. You follow the order of operations. So I have exponents here. I'll take care of my exponent. -2 squared is 4. So taking care of that part there, my exponent. Next thing is taking care of multiplication and division from left to right. So here I have 12 minus -2 times 5 is going to be a -10 plus 1. Okay, so we can rewrite that to be 12 plus 10 plus 1. We add these together, we get 23. 12 and 10 is going to be 22 plus 1 is 23. Okay. Now this next one has a fraction bar in it. So we'll replace the variable with a value. And when we simplify it, we'll simplify the numerator first completely or the denominator first completely. And this is example 2. Okay. So I have x squared plus 3x minus 4 divided by 4 minus 3x. And we let x equal to 4. In the name of the, so we evaluate this function here, replace every value with values here. Okay, so when I do that, okay, so now I start simplify my numerator first completely, take care of the exponent. 4 squared is 16, plus 3 times 4, minus 4 over 4 minus 3 times 4. Let's simplify it further. So take care of the exponent multiplication. So I'm going to have 16 plus 3 times 4 is 12 minus 4 over 4 minus 3 times 4. So addition and subtraction in the numerator, we end up with 24 here. Let's see here. 16 4 is 28, minus 4 is 24. We simplify that bottom part down. We have multiplication. So I have 24, 4 minus 12. So I have 24. 4 minus 12 is going to be a negative 8. Final answer is a negative 3. Okay. This last one here, we have a, it's equal to P 1 plus R over N raised to the N times T. So they give us values here. So we just rewrite it. P is 5,000. 1 plus R, which is 5%, which is 0.05. So you put in 0.05 here for R. And N is 12. N is 12 times T, and T is 10. Okay, so we start simplifying. In this case here, we want to do this in the parentheses first. So I have 5,000. 1 plus, and I have here 0.0041 66667. And 12 times 10 is 120. Okay. So I've taken care of what's on the parentheses. Next, I want to take care of the exponent. I'll take care of the exponent. Oh, wait a minute. Before I get that, got stuff in here I can do. So I'll add these two together, and I end up with 1.004166667 raised to the 120. So now I'll go ahead and take care of my exponent. I have one value in the parentheses. And I end up with 1.64700094976. Okay, and this gives you my final answer. 823505. The reason I had to go out so many places initially here is that we're dealing with pennies and being raised to a power. So I want to make sure that in the process of squaring and raising it to a power, I can round it to the nearest penny. Okay, so I went out to at least 8 places past the decimal, so that when I do the calculation, it'll give me the calculation to the nearest penny here. Otherwise, it can throw you way off. You wouldn't round it to 1. You have to go out to 8 or 9 places past the decimal, so you can round to the nearest penny, because we are dealing with money here. Okay.